Hey guys, it's Coach Buchanan. I'm sorry I'm not with you today. I'm at an iPad training, professional development. It's going to be great. Today we're going to talk about making an area model instead of a Venn diagram or a tree diagram. So this is the third way to do probability models. So here we go. First, we're going to begin with a rectangle. You don't have to label the size of the rectangle, but if you know the dimensions, it's easier when you have to divide the rectangle into even sections. Step 2. We're going to divide the rectangle into equal sections based on the options for the first event. So suppose we're flipping a coin. There's only two options, heads or tails. We're going to divide the rectangle evenly into two equal sections. The third step, divide each of the smaller rectangles into equal parts based on, I apologize, this should say based on the options for the second event, and so on. So here's a few examples. Suppose your first event has two options and your second event has two options. You will divide your rectangle into four equal squares, or four equal rectangles. Here's a different one. Suppose your first event has two options and your second event has three options. You'll divide your rectangle evenly into two sections, and then each of those will be divided evenly into three sections. And this one's going to be more like how you do a very difficult maze or a more difficult maze. Suppose you have three options for your first event, like you enter the maze and there's an upper, middle, or lower path, like we've done before. But then there's several options for the upper path. There's actually five if you count 1, 2, 3, 4, 5 equal options for the first row alone. For the second row, there's only two options, and for the third row, there's three options. So here, the option changes based on the first event. This is going to be a lot of the way that you might divide up a area model for a maze. And then finally, to find the total possible outcomes or the common denominator in your probability, you need to figure out how many of the smallest rectangles fit into the original triangle. So the best example I have here is that there are 1, 2, 3, 4, 5. That's the smallest rectangle I have. And if I did 5 in the first row, 5 in the second row, and 5 in the third row, 15 of these small rectangles will fit in this entire original triangle. So that's how we figure out the common denominator. So probability is probably going to be x over 15, whatever x may be, unless it can be simplified or reduced by a common factor. So that's how we're going to do area models, and what I'm going to do is do 3 examples for you. The substitute should probably be able to pause the video upon request or rewind as needed. So here we go. You guys should remember the pumpkin maze that we've done before. This is a rough sketch, but it's basically the same maze that you've seen. And we have the ability to divide this rectangle up into smaller sections to model the probability. So the first thing I want to do is show you the tree diagram that we've done for this before. The very first level of the tree had 3 branches, the upper, the middle, and the lower path. The upper path had 2 options later on, And then the middle path, you just ended up with a pumpkin. And then the lower path, you ended up with another option that will give you pumpkins or no pumpkins. So notice this is the first event, and this is the second event. So what that's going to do is going to cause your rectangle to be broken up into two different events. So the first event happens to be there are three equal options, upper, middle, and lower. It's also a good idea to label. I know that this here is 3 inches, so each section is going to be 1 inch. I would strongly recommend that you use a ruler if you have one. It would make it drastically easier. So the first option here is going to be upper path, middle path, or lower path. And what I'm going to do on the outside, I'm going to label it. So we have the upper, the middle, and the lower. And notice how those rectangles are all equally sized. They're all 1 inch by 5 inches. And so then we look at the upper path. This upper path, if we go along the upper path, it has another option. And there are 2 options or 2 choices that we could make. So that means we got to divide this rectangle in half, or divide it by 2. So if I know how big it is, which it is, shows to be 5 inches, that's 2.5 inches is halfway across this rectangle. And then I know that if I end up in either one of these spaces, I know that I'll get no pumpkins or I will get pumpkins. Those are my 2 options if I take the upper path. The middle path, if I take the middle, I just end up with pumpkins. There is no second event for the middle path. And then the lower path, there's another option, and it has 2 choices we could make. So it's exactly the same as the upper path. So I'm just going to copy that line down in the bottom because I know that that line cuts it in half. That is no pumpkins and pumpkins. So this is my area model. Now the question is, how many of these rectangles can fit in the entire original rectangle? And this is actually very simple. There's 2 in one row, so 2 in one row times 3 rows. That means there's 6 of these small rectangles. So this is 1 over 6. This is 2 over 6. And this is 1 over 6. So there are the probability to get a pumpkin. And you guys should remember this from our previous assignment. We're getting the exact same answer. 4 over 6 or 2/3 when we reduce. No pumpkins. Is 2 over 6 or 1/3. So that's how you would do an area model, and I'm trying to make sure that we see how we've done it before and how it can be done another way. So let's look at a different example. This maze is going to be quite a bit more difficult. We'll do a tree diagram and then show you how to do the area model with it. Again, if I'm going too fast, ask the substitute to pause the video. So here, take a few seconds. See if we can pause the video here so y'all can draw the maze. And then let's start with a tree diagram. Right here at the start, there are 3 options. Again, it's similar to what we've done before, the upper, the middle, and the lower path. So there's 3 options to start. Whenever you enter this maze. suppose this is the upper path. Right here, there's another option that ends up right here. Now, this is not an option because you cannot go backwards. So once you get to this point, you got to keep going forwards, and right here is your second event or your second choice. And that second choice ends up with no pumpkins or a pumpkin. Your middle path. Your middle path is right here. There are 3 options in your middle path. And then, if you notice, the middle path, if you take a couple of different of these options, there's going to be a third event. And so we'll show you how to do that here in just a second. So let's look at the middle path. If we take the middle path, there are 3 options. I'm going to do this a little bit differently. We have 1, 2, 3 options in our second event. One of those options is going to lead us directly to no pumpkins. So I can go ahead and put no pumpkins on that one. Then if we take the upper path at this point, we come to another place where there's a third event. So there's going to be 2 options here, which is pumpkins and no pumpkins. And then if we take the third option going down, here there's another third event. So this would break off here, and there would be pumpkins or no pumpkins. And then if we take the lower path at the beginning, we see that there's a second event. And that second event gives us no pumpkins or pumpkins. So here we have 3 events, and we have to divide each event equally when it happens. So it's very similarly to what we did earlier. We're going to divide the original rectangle into 3 options, just like the tree diagram. Again, you can call them the upper, the middle, and the lower if you need to. We went upper, middle, and lower. And then if you follow the upper path, there's only one other event, and it divides it in half. So again, I'm using the exact same size rectangle I used before. So 2.5 inches is half of it. And again, I can now label this. There is no pumpkins in one and pumpkins in another. The middle path, that's going to be a little bit more difficult now. There are 3 options, so I have to divide this rectangle into thirds, and that's going to be about 1.7, so it's real close to 1.75. You need to be fairly decent with a ruler in order to get this, and for the most part, as long as it's real close, I'm not going to be specific to the size that you draw. So I have to evenly divide this into 3 sections because of this point right here. And then notice one of those sections is going to be no pumpkins. But then both of the other 2 have to be cut in half. So I have to figure out what is about half of this rectangle. And if I did it right, halfway should be in the same line as that one. And then I can see halfway is about is about right there. And again, once you get into dividing these by 5, by 3, they may not be exact, but they're going to be close. Notice all 4 of these rectangles are pretty close to the same size. And so here we have 2 of those boxes should be pumpkins, and 2 should be no pumpkins. And then the lower path, there's only one, there's a second event, and that second event has 2 options, so it's going to be exactly the same as the upper path. So again, you're going to have the questions, what's the probability that you get a pumpkin? And what's the probability that you get no pumpkins? And we have to figure out how many of these rectangles go into the entire thing. And so we know that we cut this rectangle in half. So this is 1, 2, 3, 4, 5, 6. 6 of these little rectangles fit in the middle row. So 6 times 3 is 18. So we're going to put our answer over 18 and then reduce it if we can. Okay, so you should also be able to see that this big rectangle right here is equal to 3 of these. So this P is 3 over 18, which means this N is 3 over 18. And the same thing for the lower path. This one is 1 over 18. All these little ones are 1 over 18. And then this medium size one is 2 over 18. And then you just add together all the fractions. Now the reason why we find this common denominator is so we can add up all these fractions real easily. The ends, 3 plus 2 plus 3 is 8, 9, 10 over 18, which reduces to 5 over 9. Oh. I apologize about that. So no pumpkins. The ends are 3, 5, 8, 9, and 10 over 18. So no pumpkins. Make sure you get this change right here. No pumpkins and pumpkins. No pumpkins is 5 over 9 or 10 over 18. And then pumpkins, if you can read this 10 over 18, this is probably going to be 8 over 18, but we will just make sure by adding everything up. 3 plus 1 is 4, plus 3 is 7, plus another 1 is 8. So that's 8 over 18, or that reduces to 4 over 9. You should have been able to see that based on this answer. What over 9 will equal to 9? 4 over 9 would equal 9 over 9. So that was a little bit more difficult, and it's probably going to be more like what you see on a test or a homework assignment. And then we have one more that has 4 events, and I'll show you how to do that. You may need to have the substitute pause here. Suppose a carnival game consists of shooting a basketball into a hoop. Each contestant gets 4 shots. Draw an area model and a tree diagram to model this game's probability. So this is actually really simple. Each shot, you're either going to make it or miss it. So each event we know is only 2 options. If there's only 2 options, then that means our tree only has 2 branches every single time. So here's the first shot. After you take the first shot, you get a second shot. after you take the second shot, you get a third shot. And then you get a fourth shot. And so we have to label these. Let's call X make and Y a miss. So X, Y, each break has an X and a Y. I apologize, I probably should have used more space here. But hopefully y'all get the picture. All right, so every time I told you, the first shot, the first event, 2 options, so we're going to divide this rectangle in half. And this row is X. This row is Y. Our second event means we're going to have to divide the top or the longer portion in half. And very similarly, this portion or that column is X, and this column is Y. And so this is 2 shots. But now there's going to be a third shot. So we can use this side to label the third shot. So the first shot is over here. The second shot is over here. The third shot can be labeled on this side, and the fourth shot can actually either be labeled inside of the original or inside of the very small rectangles, or it can be labeled on the outside like down here. Okay, this starts to get a little bit difficult, so if you need to take a second, ask the substitute to pause. Next, the third event, each of these rectangles should be broken into half. So I am going to divide each one of these in half. Again, I'm going to do my very best to make sure everything is equal. Okay, so right here, this stands for an X, this stands for Y, this stands for X, and this stands for Y. And then lastly, we have to divide each of these rectangles in half for our fourth event. So when we do that, we have when y'all use your rulers, you might want to use centimeters. When you draw your rectangles, it might be easier to cut things in half using centimeters. All right, so what we have here, This is X. This is Y. This is X. This is Y. And if you want to check yourself at the bottom of this tree, since all the probability is equal everywhere, every event has two options, so that means probability is equal at every step, then you just count the number of X's and Y's at the bottom and you'll see there's 16. Well, here there's 16 boxes, so that means that we've done our area model correctly. Now, if you want to know more specifically about the rectangle, you might want to be able to read it to where you line up each of the X's and Y's to show how many makes each box represents. So this box right here, this is in the X, the first X row, the second X row, the third X row, and the fourth one. So this is 4 makes. This one, it's in the first X row, the second, the third, but it's in the Y for the fourth. So this is 3 makes, 1 miss. This one, first shot make, second shot miss, third shot make, fourth shot make. So this is 3 makes and 1 miss. Again, if you're having trouble with this, make sure that you ask the sub to pause or get help from someone nearby who does not have trouble with it. This box, make the first, miss the second, make the third, miss the fourth. That's 2 makes and 2 misses. This one, make the first, make the second, miss the third, and make the fourth. So this one is 3 makes, 1 miss. Make the first, make the second, miss the third, miss the fourth. 2 makes, 2 misses. Make the first, miss the second, miss the third, make the fourth. So this one's 2 makes, 2 misses. You should be able to start seeing that there's either a pattern, or you should by now be able to understand how to label each one of these boxes. I'll do one more. Make the first, miss the second, miss the third, miss the fourth. So this is 1 make, 3 misses. And this box down here, we'll jump down. This is the box where there are 0 makes and 4 misses. You guys, that's the way to do an area model. I know I'm not on campus, but I am working. So if you guys need any questions answered, I'll do my very best to monitor my Twitter account. And you can @ me or DM me if you need any additional instruction. I'll do my very best to get something to you as quickly as possible. By now, you should have an assignment, or the substitute should be getting ready to hand you the assignment for today.